Hoi Kako, this is Module 12A, Island Hydrology. Hydrology is the branch of science concerned with the properties of Earth's water, and especially its movement in relation to land. In today's lecture, we will discuss how the evolution and erosion of volcanoes on islands influences the availability of water. We will also discuss the importance of water from a Hawaiian perspective. We will cover topics like rainfall, groundwater, storms, and briefly touch upon water rights. As a reminder, all Module 12 quizzes are due on Wednesday at 8 a.m. The Hawaiians call water vai, fresh water vai, and consider vai to be sacred. Water was so valuable to Hawaiians that they used the word vai to indicate wealth. Thus, to signify abundance and prosperity, we would say vai vai. The word for law is kanewai. Since some early laws concerned water or vai rights, some have suggested that the word kanewai is derived from the word vai. However, this may or may not be the case, as many ancient edicts of gods have no relation to water. The Hawaiian word for rain is ua. Rain was beloved as it preserved the land. It was called kahiko o keakua, adornment of deity. Many rains are named and associated poetically with particular places. If you take a look here at the image on the left, you will see that this is a map of Hawaii's rainfall. Hawaii's rainfall pattern is very diverse. Annual means range from 204 millimeters or 8 inches near the summit of Mauna Kea to 10,271 millimeters or 404 inches near Big Bog on the windward slope of Haleakala on Maui. In general, high mean rainfall, shown in blue, is found on the windward mountain slopes, and low rainfall prevails, shown in red, in leeward lowlands and on the upper slopes of the highest mountains. But what is it that causes these patterns? Cloud formation leading to precipitation or rain is always associated with air that is being cooled. For any given air temperature, there is a maximum amount of water vapor that can be stored. Air containing any amount of water vapor, if cooled, will eventually reach a point where the water vapor content is exactly equal to the capacity of the air to hold water vapor. That condition is called saturation. Any additional cooling of saturated air will cause condensation to occur. Some water vapor or gas will change phase to a liquid. Water droplets or solid ice particles will form. Those water droplets and or ice particles are what clouds are made out of. The most common way to cool air is by lifting. So if you take a look here at this image on the right, air always cools when it is lifted because it moves from higher pressure to lower pressure by going up. Conversely, air that sinks gets warmer. In Hawaii, air is commonly cooled when wind blows against the slopes of mountains. Air is forced to rise. This is known as orographic lifting, producing orographic clouds and rain on the windward slopes. Because our trade winds in Hawaii blow persistently from the east-northeast direction, the pattern of cloudy, wet conditions on the windward slopes is familiar to everyone in Hawaii. This simple relationship between wind direction and topography explains much of the pattern of rainfall in Hawaii. These windward mountain slopes receive abundant rainfall throughout the year. Hanauka Ua is a book written by Colette Leimomi Akana, and it provides the names of over 200 different rains. One of the ways that we in Hawaii introduce ourselves is to introduce our name, where we come from, literally, and through the elements that represent that place. For example, our mountains, which are former volcanoes, and rain being important elements. So, for example, I would introduce myself as follows. Aloha mai o wau o hanani kane no kailua mai au o olomana ku'u mauna o mololani ku'u ua. Ola. Aloha, my name is Haunani Kane. I am from Kailua. My mountain is Olomana and my rain is the Mololani rain. For this week's quiz, you will be asked to introduce yourself using the text shown here as a template. Using the following slide, make note, or using the slide that follows this one, make note of your rain. If you're not from Hawaii, include the name of the rain where you are from, or use the name of the rain from the place where you are currently living. So again, you're going to be tested on this for your quiz. So either take a screenshot of this slide or write down this prompt here. Here on this slide, you will see a list of some of the rains in Hawaii. Note this list is not complete. For more information, please check out the references on this slide shown here. Note that the school library may have these books on file, especially Hanau Ka'ua, Hawaiian rain names. So if you're going to reference this table, notice that the first column is for the Moku Puni, or the island. So you would start by taking a look at what island you're from. Then look at the Moku district. And then in the next column, you'll see the Ahupua'a, or the land division. For example, if you live on campus, you live in the Ahupua'a of Manoa, in the Kona Moku on the Moku Puni of Oahu. So for example, here is Manoa, the wind as well as the rain. As you recall from previous lectures, in Hawaii we have something known as olelo no eau, or traditional proverbs. This olelo no eau reads, Ola ika vai aka opua. There is life in the water from the clouds. Vai, or fresh water, is essential to all life. Our mo'olelo, or stories, tell us that vai is the kinolau, or physical form of the akua, Kane and Kanaloa, the gods Kane and Kanaloa, who created new springs and streams. Most ahupua'a, or land divisions, contain a source of fresh water. Many places throughout the Pai'aina, or the Hawaiian archipelago, were named to acknowledge their freshwater resources. For example, districts or ahupua'a of Waipi'o on Hawaii and Wai'ale'ale on Kauai. In Old Hawaii, we had konohiki who acted as resources stewards for ahupua'a and appointed water tenders known as kahuvai to oversee water use. This traditional system of resource management led to minimal disputes over water rights. Ue kalani ola kahonua. When heaven cries, the land lives. This olelo no eau reminds us of the importance again of vai, fresh water, in creating and sustaining life on earth. The word ola means to live, to thrive, to be vibrant. It also means health and healing, and so in this olelo no eau, we remember that all of these things are made possible through vai, through our freshwater resources. Hahai no ka'ua I ka ulula'au. The rain follows the forest. The rains are attracted to forest trees. Knowing this, Hawaiians hewed only the trees that were needed. This olelo no eau stresses the importance of maintaining healthy forests as a means to ensure rainfall. Next, we'll take a look at this diagram. that explains the hydrology of high oceanic islands. So on oceanic islands such as the Hawaiian Islands, the water that we drink commonly occurs as a freshwater lens that floats on salt water and is separated from the salt water by a transition zone known as a brackish water. So here, freshwater sitting upon more dense salt water and separated by brackish water. Most basal water and sedimentary rocks and deposits commonly is no more than 100 feet thick, with water levels not more than several feet above sea level. Fresh groundwater generally moves from topographically high areas, like this, towards the ocean. Fresh groundwater flow is generally downward in the inland areas and upward in the coastal areas, and horizontal in between. Water beneath the land surface occurs in two principal zones, so we're going to re-emphasize this. There is the unsaturated zone and the saturated zone. In the unsaturated zone, the spaces between particle grains and cracks in rocks contain both air and water. Although a considerable amount of water can be present in the unsaturated zone, this water cannot be pumped by wells because capillary forces, or the forces between the grains, hold the water too tightly. In contrast to the unsaturated zone, the voids in the saturated zone are completely filled with water. The approximate upper surface of the saturated zone is referred to as the water table. Water in the saturated zone below the water table is referred to as groundwater. Below the water table, the water pressure is high enough to allow water to enter a well as the water level in the well is lowered by pumping. Groundwater provides 99% of domestic water and 50% of all fresh water in Hawaii. Furthermore, the water that you drink from your faucet does not come from the rain you heard on your rooftop last night. The age of the water that we drink varies based upon the geology or types of rocks in our nearby aquifer. In general, the water we drink is, say, a few decades to hundreds of years old on Oahu, and could be as old as a few thousand years in areas like Kona, where the volcanic rocks are highly porous. You may recall this image of the typical Hawaiian lava flows from a previous lecture. This image is also important when describing island hydrology. The most productive and most widespread aquifers consist of thick sequences of numerous lava flows. Pahoehoe, shown here, has a mixture of voids and fractures that in Pahoehoe flows imparts high intrinsic permeability similar to that of carbonate rocks. The layers of clinker at the top and bottom of A'a flow impart high permeability similar to that of coarse-grained gravel to volcanic rock aquifers. However, lava in the core of the A'a typically cools as a massive body of rock with much lower permeability. And finally, as you recall, dikes are thin near vertical sheets of massive low permeability rock that intrude existing rocks, commonly permeable lava flows. Dikes can extend vertically and laterally for long distances and impede the flow of groundwater. Dikes can intersect at various angles and compartmentalize the more permeable rock in which groundwater can be impounded. On oceanic islands such as the Hawaiian Islands, fresh water commonly occurs as a freshwater lens that sits or floats on salt water and is separated by brackish water. So I've mentioned this multiple times. That should be a hint of the importance for your upcoming quiz. There is this principle known as the Geibin-Herzberg principle that is commonly used to estimate the depth where the brackish water in the transition zone has a salinity about 50% that of water. The Pacific Geibin-Herzberg principle is named after two scientists who independently described a freshwater-saltwater relation. For these conditions, the freshwater lens thickness below sea level is directly proportional to the height of the top of the freshwater above sea level. In principle, at a place brackish, where the water table stands 1 foot above sea level, for example, 40 feet of fresh water will be below sea level, and thus the freshwater lens is 41 feet thick. This relationship exists because seawater is about 1/40 more dense than freshwater. In a real freshwater lens system, mixing creates a transition zone, saltwater, and reduces the amount of freshwater above the transition zone. Some places where freshwater is extensively mixed with saltwater, brackish water may exist immediately below the water table. In this image, we see there is low permeability caprock or limestone that acts as a confining unit near the coast. So this caprock is shown here in yellow. A thicker freshwater lens develops because groundwater cannot discharge as readily to the ocean. So the freshwater thickens because the groundwater cannot escape into the ocean. In this image, we see that there are weathered volcanic rocks on the surface of an older volcano, forming a confining unit between the lower and upper aquifers. So here, older volcanic rocks with younger volcanic rocks deposited above. Beneath the confining unit, shown here, the well penetrates deeper fresh water underlain by brackish water and salty water. Fresh groundwater flows from the deeper volcanic rock aquifer through the confining unit into the upper volcanic rock aquifer. And finally, saltwater intrusion is a potential problem near the coast. So in this diagram, shown here on the top, labeled A, there's a diagram of a well completed in a volcanic rock aquifer where withdrawal is small. With minimal pumping, the water table is largely unchanged and only fresh water is pumped. In the diagram below, we see the same well, however, it is undergoing large groundwater withdrawal. With high rates of pumping, the water table will be lowered and the freshwater lens will thin. In this image, brackish water is being pumped. This is really important, especially as climate change continues in the near future. Stressors such as sea level rise will need to be considered within our coastal and island aquifers. As sea level rises, salt water will intrude into the water table. The entire water table will rise towards the surface, and we will have to be even more mindful of not over pumping and reducing the freshwater lens. Next, we are going to discuss the impacts of storms upon the hydrologic system. Hueana kai I piha'a moe vai ouka. Washed to the sea is debris of upland streams. This is said of a cloudburst that washes the stones from the stream beds. Kalepo ke kumuvai e huaiana kalepo kai. When the source of water is dirty, the dirt is carried to the sea. Here is an image of Waimea Bay after Tropical Storm Darby hit. According to the Hawaii Clean Water Branch, during large storms, we typically have brownwater advisories. This advisory warns the public that they should stay out of beaches or streams that are contaminated by storm or brown water. Storm water can contain harmful microorganisms or pathogens and other harmful pollutants from overflowing sewage systems such as cesspools or septic tanks and animal feces flowing into storm drains. The Clean Water Branch provides updates on water quality advisories, including brown water advisories and high bacteria counts across Hawaii. I've provided the link for their website here. Now we will look more closely at Hurricane Lane. In August 2018, over a 4-day period, Hawaii Island received, on average, 17 inches of rainfall, with a 4-day single station maximum of 57 inches, making Hurricane Lane the wettest tropical cyclone ever recorded in Hawaii. The resulting floods and landslides caused extensive damage and 1 fatality. More than 3,000 insurance claims for damage were made statewide with a total economic loss exceeding $250 million. Although Hurricane Lane remained west of Hawaii Island, tremendous amounts of rain battered eastern areas of the island from August 22nd to the 26th. Accumulations were greatest along the eastern slopes of Mauna Kea, with a maximum of 58 inches at Kahuna Falls in Akaka Falls State Park. This made Lane the wettest tropical cyclone on record, surpassing previous peak of 52 inches during Hurricane Hiki in 1950. Lane's peak rainfall total was also the second highest recorded from a tropical cyclone within the U.S. Hilo saw its wettest 3-day period on record with 31.85 inches of precipitation observed. 15 inches fell on August 24th alone, making it the 5th wettest day in the city's recorded history. So here is a table where you can see the combined 3-day total rainfall record at various rain gauges across Hawaii Island and Maui. This figure here depicts just how quickly the rivers will fill during a storm. This figure in particular is for Wailuku River. Wailuku literally means water of slaughter. If you have grown up in this area or spent much time in Hilo, you know that streams are to be avoided when it rains. Please, you guys, do not go hiking or visit waterfalls during a storm. I'm serious, this is no joke. Next, we'll go through a series of images depicting just how much water was received during Hurricane Lane. So this image here on the left shows Wailuku River during normal flow on the left and during Hurricane Lane here on the right. And for reference, you can see this house here is the same house that's shown here. So during normal flow, you see a series of ailele or waterfalls, and during Hurricane Lane, all of the rocks, including the waterfalls, were completely covered in water. Again, here's another image of Wailuku River during rainfall. During Hurricane Lane, you can see just how much water there is here going under this bridge. Here's another waterfall, Rainbow Falls. Rainbow Falls during normal flow here on the left, and again, the waterfall is completely engulfed during Hurricane Lane. Another image showing heavy stream flow north of Hilo after Hurricane Lane. See how just how brown these rivers are. And many of these rivers also have lava tubes at their base, which makes it even more dangerous to swim, especially during high rainfall and stream flow events. Here is an image of the soccer fields, so the flooded soccer fields after Hurricane Lane. So this area here is the gas station. This is one of the main coastal roads in Hilo. This area here and this area here is a parking lot, and then this large park is the soccer fields, and you can see they're completely underwater. And this region was actually a wetland that was fed by multiple streams prior to being converted into soccer fields. Again, here is another image. You can see large portions of debris being washed out into this area, including trees, rocks. And as we transition towards the end of this lecture, I wanted to just share this with you. Hawaii's drinking water is protected under the Hawaii State Constitution through the public trust doctrine. So Hawaii is one of several states that have included the public trust doctrine into its state constitution. As stated earlier, the legislature incorporated the public trust doctrine into the state water code as follows. It is recognized that the waters of the state of Hawaii are held for the benefit of the citizens of Hawaii. It is declared that the people of Hawaii are beneficiaries and have a right to have the waters protected for the use. So Hawaii's constitutional, statutory, and administrative rule provisions for protecting public interests were reinforced by the Hawaii State Supreme Court decisions in the Waihole Ditch contested case, proceedings during the late 1990s and early 2000s. The court's decisions emphasize the public trust doctrine and the associated precautionary principle as essential to the application and administration of the state water code, and have further helped to define current water rights here in Hawaii. So our water resources, along with a number of other natural resources, are seen as being a public good, and because of that, they are protected under Hawaii State constitutional law. And that is the end of today's lecture. If you're interested in learning more about water rights, I encourage you to take a look on the internet. There have been a number of cases, most recently being those associated with Red Hill, as well as on Lahaina, Maui, and even before those two cases, extending back further into the past, where the communities of Hawaii have taken corporations, public, private, to court as a means to fight for the protection of our drinking water.